Drew Herrera is originally from Wright, Wyoming, and earned a BS in civil engineering from the University of Wyoming. He has worked in the mining industry for the last 13 years in Wyoming, Idaho, and Montana in coal, phosphate, and hard rock mines. Aside from managing HGL's regional mine reclamation group, Drew currently manages and oversees O&M at the abandoned Zortman and Landusky mines located in north central Montana. Drew is a registered professional engineer in Montana, Wyoming, Colorado, Utah, and New Mexico. Please join me in welcoming Drew. Thank you.
Okay, thanks guys. So a quick raise of hands. Anybody here from attend in 2012? 1, 2, 3. Okay, that's not too bad, because at about 8 o'clock last night, I was looking through the old files, and I saw this exact same title on a presentation in 2012 from Wayne, Warren, and Bill Mayle. So, but I assure you this is not the exact same verbatim presentation. So so I'll just a little introduction. I work for Hydrogeologic, or HGL. We were formerly Spectrum Engineering. Back in July last year, we switched over. We'd been purchased by HGL for the past 7 years, and we just became under one building, basically, or one roof last year. I got 3 kids, 9, 7, and 2, so it's a pretty hectic time. It's exciting. So we're going to be talking about the Zortman Landusky, just extreme weather events. I know this is a pretty exciting topic. It's a kind of an interesting, because I don't know if any of you guys have ever been up to the Little Rocky Mountains, but it's just north of the Missouri Breaks, and it's this big island mountain range that just kind of rises up. On the left-hand side right here, you can see some of the forest fires, flooding on the right-hand side, upper right. With the flooding comes landslides from the steep historic mining that's gone up there. And then, of course, it's Montana, so we're also going to get some snow. So today we're going to talk about, first we're going to show you the drainages, because a lot of stuff with Zortman Landusky is involved with the different drainages. So I think it was a pretty cool map that I came across that kind of describes where everything's at. It's kind of a tri-basin divide. We'll discuss some of the yearly precipitation and how it's kind of tracked since the mid-90s. Pretty interesting. Obviously discuss the floods from 08, 2011, 2013, 2019. Kind of seen a pattern here. And then in between there, those other years, forest fires, 2017, 2021. And then lastly, we'll talk about the Swift Gulch improvements. Swift Gulch is the drainage on the north side of the mine. It's a very, very important drainage as it discharges onto the Fort Belknap Reservation. I'll kind of talk a little bit about that. But some of the improvements have been capture systems, capturing the acid rock drainage, improving the high flow treatment there during these big storms, and then some future stream restoration projects. Always forget to talk about photos. That's our friend right there. There's a great group of bighorn sheep up in the mine. So if you ever get a chance to get up there, they're very friendly. They'll actually walk right up to your cars. Yep. All right, so this is just an overview of the 2 maps. Landusky's on the left-hand side. Zortman's on the right-hand side. With the Landusky side of things, you often hear Montana Gulch, Mill Gulch, Sullivan Gulch. Those are the 3 that are basically going through the town of Landusky. And then on the north-hand side, you got the Swift Gulch, which turns into the south, Bighorn Creek. And all that flows onto the Fort Belknap Reservation. 2 pretty important areas there. And yeah, we'll get to that a little bit later. On the Zortman side, we have Ruby Gulch and Alder Gulch. And I don't know if you guys are familiar or know the background of Zortman Landusky, but it was owned or operated by Pegasus. Went bankrupt in the late 90s, went over to the state, and basically the state's been running it since the early 2000s. And just saw you there, Wayne. If I get anything wrong, just let me know. Okay. Yeah. All right. So Zortman Landusky, we do a lot more of these reclamation projects. We're just trying to get more data, trying to look at what is out there as far as what do we size any of the stream restoration, any basins to. This is just a little background information. The big map on the right-hand side is just the NOAA Atlas II, Volume 1. I think this map's from the 1970s. But if you zoom right into where that circle's at, it's 40/10 of an inch. So 4 inches is basically the 100-year, 24-hour storm. I also use Carlson software, and it has an internal thing where it uses the TP40, TP47. Again, that's NOAA data. And it all basically confirms these same things as of right now, that the 10-year 2.6, 25 years 3.1, 50 years a 3.75, and the 100 years basically a 4-inch event. Something that's interesting is that the NOAA Atlas 14 Volume 12 is coming out in 2024, so it'll be an updated of this. That'll basically be Montana, Idaho, and Wyoming, so very excited to see the hydrologic maps there. So this is the yearly precipitation at the Landusky site. The Zortman site can be slightly different, but generally they follow the same. We can have some big storms at one side or the other as well. Some noticeable things is that we start in the early 90s. 1994 is when we started tracking, and remained pretty consistent up until the mid to late 2000s. And then when we get to the mid to late 2000s, you start seeing these big jumps back and forth. A couple notable events is in 2008, in June, we had, of 25 days, we had 20 days with precipitation. In 2011, 7.25 inches in 3 days. In 2013, 6.7 inches in 4 days, 2-day break, and then another 4.5 inches in 2 days. 2016, we did have floods, which you'd see it's on the high side, one of these high points right there. But luckily, most of those storms just were evened out through the wet season and no damage. And then as you see these big spikes, on the downside of things, 2017 forest fires where we had 13.74 inches of moisture. Back up in 2019 with 6.85 inches. And then in 5 days, huge storm. And then in 2021, another big year of forest fires, which we'll talk about later, with only 10.76. With notably that 10.76 the lowest we've had on record up there. A couple more kind of interesting things to talk about here is these one-day storms that we've been tracking. So I don't know if you paid attention, but the NOAA Atlas stuff said a 100-year storm event was 4 inches. Well, basically we've gotten 3 of them since 2011, and pretty close to one in 1997 as well. So when we go to design all these features, we got to keep that in mind, that this is, you kind of have to look at actual site data, what's going on up there, and what are we going to predict in the future. So some of these cool old photos of some of these big events have happened up there. This is 2002, the Ruby Gulch Pump House. Basically, there's a pond right up above this, and in 2002, the pond above it overflowed after there was lots of moisture, big heavy year again, overflowed the pond, which then saturated the dump, and then basically the whole dump slid into this barn, shut down the pump house for a month. Let's see. This is a different view of the Ruby Gulch Pump House in 2008 and 2011. So as you can see in the right-hand side, they cleaned that area up pretty good. They got, in 2002, they went back in there and cleaned all those tailings up. The biggest thing that we're seeing on these old mine sites is just maintenance, right? These are not geomorphically stable waste rock dumps. So over time, they're going to have issues, they're going to have maintenance. So let's kind of show on the left map right here, you can see that this run-on control ditch has breached. Now we have water running down, getting into this, right? Luckily, it's been fixed, and in 2 years later, in 2011, you can see that it's actually running the way it's supposed to, but now we got water running on this side of things, right? So in the 2008, there's another large event that occurred, and in 2002, they just tried to pump the water. They didn't want to release it. It's about a 3 pH water that's reporting to there. This in 2008, they just decided to discharge the water, releasing about 38 million gallons of about 3 pH water. Fortunately, dilution with the rest of the storms, there was no significant issues downstream of this. But instead of having another dump failure, we had, chose to release the water instead. Just a couple photos from the Zortman site, or the town of Zortman. Obviously, some of these big, creeks overflowing in here on the right-hand side. Hard to get there at the peak of the storm when you got peak discharge going on, but you can see definitely some big cuts going on in there. Let's see. In 2011, this is the Alder waste rock dump. It has about a 70,000 gallon pond up above it. And again, overflows over these, 70,000 gallons isn't a whole lot at the term of these storms. The pond started overflowing from May 21st to June 19th. This was that really long storm. 16 million gallons went over the edge there, which resulted into this big landslide. This is kind of looking across at it. This is looking downstream into Carter Gulch, which is just down below it. In total, about 150,000 yards sloughed down. These next two photos are looking in Carter Gulch, down looking upstream at the Alder Gulch. Kind of confusing there, but this is a pump back station right here. It wiped all of that out. In total was about $500,000 worth of damage that it took to rebuild everything. Let's see, 2011 and 12. So talking Swift Gulch. This is the mine drainage that's on the north side of the mine. It has about 1,000 acres that drains to it. And then in 2 big years in 2011 and 13, saw about between 500 and 1,000 CFS flowing through there. Caused some major damage, wiped out the road. This is Mission Canyon on the Fort Belknap Reservation. This photo on the left-hand side is Swift Gulch right here. This green building right here is the water treatment plant. Luckily, we had some great operators that during the peak discharge, there was an excavator sitting down right over here. He climbed up and over the mountain, hopped in the excavator to come check on things, saw that this was overflowing, and we were probably hours away from the whole plant getting washed downstream. Gerald Martin, he hopped in the excavator, opened up the creek to allow more flow down into here. So big kudos to the operators up there. Just another photo further downstream into Mission Canyon in 2013, showing these big 6-foot culverts that have been washed out. So, we talked about some of the highs with the precipitation, the big high precipitation events. Now we'll kind of talk a little bit about the lows. 2017, 13.74 inches, and then 2021, 6.76. This is the 2017 fire. It started near near the town of Zortman. Is basically burned from July 3rd to July 15th. Took out about 12,000 acres of land. This is kind of a neat photo right here. This is showing the recovery, just like the previous talker was talking about, that once that vegetation gets established, it's amazing how well it comes back. These two photos are kind of looking opposite at each other. So this is the biological treatment plant right here. You can see the fire break with the road, right? So we're looking the opposite direction. So everything north of this road right here is what was impacted by the fire. So just 2 years later, we had, basically full recovery. The other fire was in 2021, the Pine Grove fire. This was on the north side of the mine. Didn't have any really good maps to show on this, so hopefully you can use your imagination. But here's the mine site down over here. This started near the town of Hayes and came up north. Burned about 17,000 acres. And then to kind of show that this is the 2017 fire, which was on the south side of the mine. So 17 was on the south side, 21 was on the north side. We've had a little bit of damage from the forest fires, but I think with all the roads that are up at the mine, they actually do provide pretty good fire breaks. And the same thing, you know, it's just amazing to have the resources that we do up at the mine. One of our operators lives in the town of Hayes. He hopped on one of our blades and was able to cut some fire lines and save some properties, because you can see that fire came really, really close to that town. All right, so the last thing we'll talk about is the Swift Gulch drainage. So we're talking about extreme events right here. Swift Gulch, it's called Swift Gulch for a reason. It's got about 2 to 1 side slopes. Starts off at maybe a 2 to 4% grade in the bottom of the drainage, and then it goes up to maybe a 10% grade as further up you go. This photo right here is just showing, this is kind of the outline of what Swift Gulch is. You know, this is the Landusky mine on the right-hand side, the Queen Rose and the Surprise Pit. So what's interesting is that during mine life, there was no acid rock drainage issues in Swift Gulch. It was only 5 to 10 years after bankruptcy occurred that acid rock drainage seeps started occurring down this area right here. So unfortunately, there was no bond set aside, there was no funding set aside, so the state basically had to figure out what they were going to do, how are they going to try to mitigate this. So over the past, basically between 2012 and now, we've basically piecemealed a water treatment plant, which is further on down near the blue circle over here. This just shows you some recent photos of those iron seeps that are further up on Swift Gulch. Just looks like just a seep coming right out of the hillside. And it's interesting that it does occur on both the south side and the north side of the drainage. They have dated these back to like maybe 10,000 years. So back in geologic time, there has been issues. There has been acid rock drainage going through there in the past. What happened between mining when they stopped to when after reclamation occurred, nobody really knows, but now we have pretty much 60 gallons a minute of acid rock drainage precipitating or coming out of the seeps right here. The photo on the right-hand side is our crew, Jim, Bill, and Mike. You can see Jim decided to dye his pants on the way down. I don't recommend getting the iron on you. There's nothing wrong with it. It'll stain your clothes pretty quick. Yep. So I borrowed this from some of Wayne's old things, but it kind of shows you that, you know, at the end of mine life, now it's kind of an old photo, but there really isn't acid rock drainage issues in here. It was only after that these iron plumes, these ferrocrete, pools really started migrating downstream. Another interesting thing with Swift Gulch is that prior to all this active mining, or the mining basically from the 1970s to the late 1990s, mining went back as far as the 1800s. So in the early 1900s, this is the lower reach of Swift Gulch down here. So in the early 1900s, they dammed this off and they floated a dredge out here, and they actually did placer mining in the bottom of here. What's interesting is they stockpiled these dredge piles up on the north side and the south side. Those will be important to talk about later on when we talk about stream restoration. But if you go out there and walk around, the vegetation and the trees have come back so heavy that you really can't see, which I'll show in the next photo down here. These dredge piles are right down here. Without having these LiDAR data, it's really hard to even see that they were there. But since we have LiDAR data now, we're able to get some rough estimates. This is a 1.5 to 1 talus slope that they just deposited these tailings on. So as you project it through, we got about 18,000 cubic yards of material that have been thrown up on the slopes there. Just a quick discussion on the actual treatment process. This is the Swift Gulch Water Treatment Plant. It's just a regular lime slurry, lime precipitation plant. Uses a lamella-style clarifier in this building right here. This photo is looking downstream from the plant. It's always important to kind of talk about what we're dealing with when we want to talk about stream restoration. The biggest issue with stream restoration in this area is the infrastructure in place. So we have a road that we need to keep access all the way up to the plant, and then we have these sludge pits that we use to decant the water or decant the sludge. Once a year we get in here and we excavate the sludge out, haul it back up to the lined pit, but it really just kind of keeps the operation going to having those pits right there. So one of the big improvements that we had was in 2018. We decided we were going to build a capture system. Now upstream, we have these basically concrete cutoff walls that we've used to capture the water up there, but in the wintertime, we just could not get over the freezing issues because it's just terribly cold up in there. So to help capture water all year round effectively and to help mitigate any of these high flow events, we built the Swift Gulch sediment retention structure, which is basically a small dam, an impoundment that we built to help capture. Now we have a drain pipe that's in the bottom of this that does report straight to the water treatment plant. Now what's interesting is that when I designed this, we looked at the 100-year event. We did the calculations. It was like 500 CFS coming through here, 500 acres draining to it, and we just doubled it. Whatever the size was for 1,000 or for a 100-year event, we just went ahead and doubled it, which was really important because we built it in October, and in June the following year, we basically had like a 150-year event that came through. Luckily, we'd sourced some amazing giant riprap out of Chinook. It's the same riprap that they use at the Fort Peck Dam, the spillway that they're using up there. So, I think by doubling it, having a 100% safety factor, I think it worked out pretty good for us. This getting near towards the end here, just kind of touch base on some of the stream restoration that we plan on doing up there is, so I showed you that previous photo, this one right here, right? We have this main stretch, and then right here we have the South Bighorn that's coming into Swift Gulch, and it turns the corner. That's going to be our plans for going forward in 2023 and 24. Like I described earlier, we got these dredge piles that are up on the slopes here. I've kind of have them highlighted in red right here. Again, really difficult to see, but having all that vegetation is going to work out pretty good because we're going to implement a stage 0 stream restoration in here. This lower cross section down here kind of gives kind of a conceptual of what we're talking about. We have these dredge piles that are up on the hill slope. What we're going to do is bring those dredge piles back into the creek, widen out the creek bottom, and then place the slash and all the trees and all the timber and go back to this stage 0 stream restoration. It's a pretty good candidate, pretty good place to try this because we do have all these dredge piles out here. We've been meeting with the Forest Service and the BLM in the area, and I think everybody's excited to get this project kicked off the ground and basically reclaim all these dredge piles. So with that, I'll just kind of take some questions, but say thanks to Wayne and to Dan for inviting me up here, and the BLM crew that's given some funding for some of the projects that we're doing up there. Also the DNRC, they're funding the stream restoration and the high flow treatment that we're doing up there. Then of course the HGL staff, Mike Shrell, Kevin, Mike, Mummy, they've been up there for over 30 years apiece, so pretty amazing the dedication that we have up there. So with that, I'll take some questions.
Question back here.
So did you face any resistance on the stage 0 concept from your regulators? I mean, normally that will lead to a good bit of sediment headed down.
No, we're not really. Actually, I was probably the most one that was pushing back against the stage 0, and the regulators have actually been the ones that have been really excited. I think they see the opportunity that's there. They see that it's just a great candidate to implement that style of restoration in that area. It checks a lot of the boxes when you're looking at sites for that.
Any other questions?
Are you facing any access restrictions? How's that working with that private landowner?
Yeah, we are. Luckily, there is laws in place, or basically when it went through bankruptcy, we were able to say that the state does have access up there to do operations. He's being a little bit more hostile to other people coming up there, specifically the Fort Belknap, which is unfortunate. We do hold our technical working group 2 times a year up there, and instead of this year being up at the mine offices, we're going to be down on the reservation, which we're excited to continue working together with the Fort Belknap down there.
Thank you.
Yep.
Any other questions?
Find any, when that flood happened in Smith Gulch and made all the gully in, did you find any good ferrocretes?
Yeah, and we actually found a lot of ferrocretes when we built the small impoundment there as well, right? It's because we wanted to dig down into bedrock as far as we could, and you can see ferrocretes all the way down. Like I said, they've tested it in previous studies, and it's gone back to 10,000 years that's in the stream itself. So pretty interesting that it all came through. Something happened a long time ago to send ferrocretes down it, and then the active mining, didn't happen during mine life, right, when they were doing inspections up there. But then something opened up, maybe some dewatering stopped, whatever it might be, and then it's picked back up again.
Any more questions? All right. Thank you, Drew.
All right, thanks, Dan.